Dr. Sadhna Singh. It's my another lecture of structure of atom. Last time we studied Bohr model of atom, and we have seen that Bohr model has some limitations. Among his limitations, there is one limitation in which when the spectra of hydrogen atom is seen by the high power magnified microscope, then each line has many fine lines which cannot be explained by the Bohr's model. To explain about these fine lines, Somerfield put a model of elliptical orbit. Somerfield model of elliptical orbit, he said that electron revolves in an elliptical orbit around the nucleus. He said when electron revolve around the nucleus in an elliptical orbit, it has two axes, major axis and minor axis. For an elliptical orbit, the value of major and minor axis may change. If the value of major axis decreases, and then the value of minor axis increases in the same way, so the ratio remains constant. And if this happens, then there is a formation of another elliptical orbit, which is the suborbit of that elliptical orbit. For an elliptical orbit, he said by changing the value of major and minor axis, there may be a time where both the axis becomes equal. The major axis and minor axis both become equal, and when it happens, then the elliptical orbit becomes an circular orbit. So, due to the change in values of major and minor axis for an elliptical orbit, elliptical orbit has suborbits, and among these suborbit, if both the values of major and minor axis becomes equal, then the elliptical orbit becomes a circular orbit. So, the circular orbit of Bohr is the form of elliptical orbit of Somerfield in which both the axes become equal. So, according to the elliptical concept of orbit, each elliptical orbit has suborbits. How many suborbit an elliptical orbit can have? This depends upon the value of angular momentum. The angular momentum depends upon two factors, that is the radial factor and the angular factor. The value of angular momentum is sum of radial vector and the angular vector. Now, if it is the first orbit, then the value of angular momentum mvr is equal to h upon 2 pi, and the value of nr and theta will be, if nr is h upon 2 pi, then n theta is 0. So, the first orbit, there is no suborbit, it is only one orbit in which nr is h theta, then n theta is 0. For the second orbit, where mvr is 2h upon 2 pi, then the value of nr and theta will be, if nr is h upon 2 pi, then n theta will be h upon 2 pi, and if nr is 2h upon 2 pi, then n theta will be 0. For the second orbit, mvr, for the second orbit, the value of mvr will be of two type, this and this. So second orbit has two suborbit. Similarly, if it is a third orbit, then the value of angular momentum mvr is 3h upon 2 pi, which can be obtained by the values of nr and theta. Like this, if nr is 3h upon 2 pi, then n theta will be 0. If nr is 2h upon 2 pi, then n theta will be h upon 2 pi. And if nr is h upon 2 pi, then n theta will be 2h upon 2 pi. So, for the third orbit, there are three suborbits. Similarly, for the fourth orbit, where mvr is 4h upon 2 pi, the values of nr and theta are this and this and that. So, the fourth orbit there are 4 suborbits, and for the fifth orbit there are 5 suborbit whose values are this, and this. So according to the Somerfield, electron revolve in elliptical orbit which has 2 axes. By changing the values of major and minor axes for each elliptical orbit there are some suborbits, and how many suborbits can depends upon the value of angular momentum, which depend upon two factor nr and theta. So each elliptical orbit has some orbits, and each elliptical orbit has fixed some orbits. The first orbit has no suborbit, it has only one orbit. Second has 2, third has 3, 4 has 4, and 5 has 5 suborbits. Now, if electron revolve in an elliptical orbit, then the electron in an elliptical orbit at different position has different distance from the nucleus. Somewhere it is far from the nucleus and somewhere it is closer to the nucleus. Now, when electron is far from the nucleus, then it has less attraction force of the nucleus, and when it is closer to the nucleus, then it has more attraction force of the nucleus. So when electron revolve in an elliptical orbit, its attraction force changes at different positions. Somewhere it is more, somewhere it is less. Due to the change in attraction force of the nucleus of the electron in an elliptical orbit, its velocity also changes. When it is far from the nucleus, where it has less attraction force, its velocity is more. When it is near to the nucleus, where its attraction force is more, its velocity is less. Now, revolving electron in an elliptical orbit, due to the change in velocity, to keep its momentum constant, its mass also changes, so the product will be constant. By changing the mass of electron in an elliptical orbit, the orbit also starts moving on its own axis, and this type of movements are known as precessional movements. The orbit also revolve on its own axis, and these type of movements are known as precession movements. Each orbit has different precessional movements. Due to the change of precession movements, the energy of each suborbit also changes. So the energies of elliptical orbit, the energies of suborbits are not same. They are different energies, so they have different energy levels. So each elliptical orbit which has suborbits, their energy levels are not same. Due to the precession movements, they have different energy levels. So when electron, after absorbing energy, when it goes from ground state to higher energy level, and when it falls back, then each energy level has some energies. So they have different lines of emitted energy. For example, in a Balmer series, the electron moves from ground state to the third energy level, third orbit, and when it fall from third to the second orbit, according to the Bohr, there is only one line from third to second, but according to the Somerfield, the third orbit has 3 suborbits which have different energy levels, and the second orbit has 2 suborbits which have different energy level. So when electron fall from the third orbit to second orbit, it emits different energies and it has different lines. So each line of the spectra for a Balmer series has many fine lines because they have suborbits of different energy levels. So this limitation of Bohr is overcome by the Somerfield concept of elliptical orbit. But to explain the other limitations of Bohr model, there are some other models given by the scientists. So next we will study the de Broglie concept of atom. Thank you.